So, hello everyone again. This is lecture 4 part 3 of communication systems. I am Sameer Lavankar. Let us move on with our mathematical formulation which we ended up at last in the last part. So, we were studying about amplitude modulation. Let us move on with our amplitude modulation concept only. So, in the last lecture we concluded by this statement. Let me you complete the mathematical formulation here. So, after this point it is B A M sin omega mt plus BAC sin omega ct plus CAM square by 2 minus CAM square by 2 cos of 2 omega mt. There will be a t here plus CAC square by 2 minus CAC square by 2 cos of, there will be a t here again, cos of 2 omega ct plus CAM AC cos of omega m minus omega c into t minus cos of omega m plus omega c into t. So, if you can see here clearly, so this is the first line written here, this is second line, next is CAM square by 2, next is minus CAM square by 2 into cos omega 2 omega mt, next is minus CAC square, this is the second, this is the next line, there will be a plus here, this is plus also, next is minus CAC square cos omega C2 omega ct, and next is CAMAC cos omega c minus omega mt, and next is minus CAMAC cos omega c plus omega m into t. So, this is the only typical formulation I was talking to you in the last two parts. So, it is done, just a simple mathematical formulation using these two trigonometric identities is being done here, and hence we got the final square law device output, that is y of t. So, why there was a need to do this is iterated in the next slide. So, in the above equation there is a term which is c by 2 into am square plus ac square. What is that equation? This plus this. So, when you will add this term we will get c by 2 into am square plus ac square. So, this is a term here. So, in the above equation there is a DC term which is c by 2 into am square plus ac square, and sinusoids of frequencies. These are the frequencies of sinusoids. What is a sinusoid? Any sine or cos function is a sinusoid. So, you can find, like let us say this, let me change the color. So, you have a sinusoid frequency of omega m, then next is you have a sinusoid frequency of 2 omega m. Where is 2 omega m? Here it is a 2 omega m. Then next is omega c, then there is a omega c here, then next is a omega 2 omega c. So, 2 omega c is written here again, where it is 2 omega c, this is 2 omega c, and next is omega c minus omega m and omega c plus omega m. So, this is omega c minus omega m and this is omega c plus omega m. Please make sure cos of minus theta is equal to cos theta, hence writing omega m minus omega c or omega c minus omega m is same only. So, first line is being done here then. So, first line is being explained clearly. What does it explain to you? So, in our equation there is a term which is dc by 2 into am square plus ac square, and sinusoids of frequencies omega m, 2 omega m, omega c, 2 omega c, omega c minus omega m and omega c plus omega m. Now, as shown in the figure below, so these are the two figures. This signal is passed through a band pass filter. So, y of t is being passed through a band pass filter which rejects DC, rejecting DC as in rejecting this term. So, why was there is a need to know the exact terms, exact formulation? This was the need to, we need to understand what does band pass filter rejects. So, band pass filter rejects DC and the sinusoids of frequencies omega m, 2 omega m and 2 omega c. So, omega m, 2 omega m and omega c, sorry 2 omega c is being rejected and retains the frequency. So, I will just to make it more clear, I will use two different colors. So, rejected frequencies are this, noted by red color, omega m, 2 omega m and 2 omega c, and the frequency which are accepted or which are retained is omega c omega c minus omega m and omega c plus omega m. So, just to make sure why from where these sinusoids are coming, this was the main aim for me to explain to you the complete formulation of how that equation came. So, quite clear now that these frequencies written in red color are being rejected and with a DC sign, which is with a DC term, and the frequencies which are written are omega c minus omega m and omega c plus omega m. So, let us move on next. So, the output of the band pass filter is an AM wave, quite clear. Anything which comes out of this band pass filter is known as an AM wave. What is an AM wave? AM is an amplitude modulated wave, amplitude modulated wave. Now, next is, it is to be mentioned that the modulated signal cannot be transmitted as such, quite clear, it cannot be transmitted as such, it needs some more peculiar information or may need amplification because it is attenuated, it may need antennas and so on. So, this concept will be told now. So, next is the modulator. So, this was the modulator. The modulator is to be followed by a power amplifier. As the name suggests, what will a power amplifier do? It will increase the strength of the modulated wave. So, how it will increase the strength? It will try to increase its amplitude. After increasing in its amplitude, there will be an increase in strength, and hence it will be more easy for the amplitude modulated wave to get transferred from point A to point B. So, the modulator is to be followed by a power amplifier which provides the necessary power, and then the modulated signal is fed to an antenna. This is a antenna of appropriate size. Please make sure that if the wavelength to be transmitted is lambda, at least the size of the antenna should be lambda by 4 for radiation as shown in the figure below. So, line is quite clear. After amplitude modulator, it is sent to a power amplifier, and after a power amplifier it is sent to an antenna for transmission. Quite clear. One of the major lines from every concept we talked about in the last 5-10 minutes is a band pass filter rejects low and high frequencies and allows a band of frequencies to pass through. These are a band of frequencies, omega c minus omega m, omega c plus omega m, and carrier wave is required only because carrier wave is the major concern for the transmission of a low frequency from a point A to point B, and side bands are required, band of frequencies are being allowed. So, a band pass filter rejects low and high frequencies and allows a band of frequencies to pass through. So, please remember this concept. Let us move on. So, next point is now what will happen in the receiving antenna. So, this concept was about the production of the amplitude modulated wave, this was about the production of amplitude modulated wave. Now, we will understand the concept of detection of amplitude modulated wave. So, now in the detection of the amplitude modulated wave, the transmitted message gets attenuated in propagating through the channel, quite clear. When it will pass from point A to point B, there will be leakages happening, and hence the signal's strength will get reduced, and hence it will get attenuated. The physical term or the physics term for the decrease in the strength is known as attenuation. So, the transmitted message gets attenuated in propagating, that is moving or transmitting or moving or passages from point A to point B through the channel. Channel can be wired or wireless. The receiving antenna is therefore to be followed by an amplifier and a detector. So, receiving antenna is to be followed by an amplifier and then a detector, quite clear from the diagram shown below. In addition, so you may understand, you may think of why there is an IF stage box being created here. So, to explain that, in addition to facilitate further processing, the carrier frequency is usually changed to a lower frequency by what is called an intermediate frequency stage preceding the detection. So, just before detection there is a different block diagram, or there is a different device being used in which the carrier wave is being changed from a high frequency to a low frequency. The stage in which this is done is known as a IF stage. IF stage is nothing but intermediate frequency stage. So, in addition to facilitate further processing, the carrier frequency is usually changed to a lower frequency by what is called an intermediate frequency stage preceding the detection, as in before the detection. The detected signal may not be strong enough to be made use of, and hence is required to be amplified. Quite clear that a detected signal will not be because after detection has been done, there may be again a reduction in the strength due to attenuation or any other different things which may cause in a detector. Due to that, there is an amplifier required again for the amplification of the signal strength, and hence 2 amplifiers are being used. So, the detected signal may not be strong enough to be made use of, and hence is required to be amplified. And finally, conclusion is the block diagram of a typical receiver is shown in the figure below. So, this is the typical block diagram for receiving part, that is receiving antenna and so on, and finally output, and this is for the message signal. So, this is how the modulation is being done. Finally, more about detection. So, detection is the process of recovering the modulating signal from the modulated carrier wave. So, finally, what we need is we need to separate, we need to retrieve the information after receiving. So, what we need as it was a combination of a carrier wave and a message signal. So, to get the output of a message signal, we need to separate both the terms. So, this is detection now. So, detection is the process of recovering the modulating signal from the modulated carrier wave. So, we just saw that the modulated carrier wave contains the frequencies omega c and omega c plus minus omega m, as it was explained to you in the mathematical formulation also, that the modulated carrier wave has the frequency omega c plus minus omega m, because the band pass filter has already rejected all other frequency which were not omega c or omega c plus minus omega m. So, in order to obtain the original message signal, that is m of t, which has a angular frequency omega m. So, omega m subscript denotes message signal. A simple method is shown in the form of block diagram in the figure below. So, what happens is this AM wave is passed through a rectifier. After it is passed through a rectifier, the below thing is being removed. So, it is just this portion, and after this, after passing it through an envelope detector, we can directly get our message signal. So, finally, we will get a message signal in the receiver end also. So, just to explain the concept written below. So, the modulated signal in the form given in A. So, this is the form of modulated signal, that is if the complete formulation I told you is being passed through band pass filter, we will only have the term which has a frequency of omega m plus omega c and omega m minus omega c. So, the addition of those all terms we will get a frequency, or we will get a wave which is in this form. So, after it is passed, so the modulated signal of the form given in A is of figure below is passed through a rectifier. It is passed through a rectifier to produce the output shown in B. So, after this, the output which we get after the rectifier is this, which is also known as rectified wave. So, this envelope of signal B is the message signal. So, this is the envelope which is the message, this has some message signal being intact to it. So, now in order to retrieve m of t was the message signal, the signal is passed through an envelope detector. So, now what we will do is envelope detector will detect the envelope, remove it, and finally, what we get the output is as the message signal. So, in order to retrieve m of t, the signal is passed through an envelope detector which may consist of a simple RC circuit. So, what does an RC circuit do? It converts the wave, rectified wave, into output wave which is without any RF component. So, finally, we will get our message signal, and hence the concept of demodulation is also being done. So, this was the complete chapter of communication systems. Just to iterate to you the course progress first, then I will move to summary in the remaining part. So, finally, the course progress is here. We started with lesson number 1, which was introduction, that is introduction of communication system. In that we studied about why there was a need for communication system, what are the different methods, how it was dated back, what was the evolution of communication systems in the last 300 years. It started with the drummers using information to pass from king to the society, then we upgraded it to telegraph, then telephone came, then there was the use of radio, FM signals, then television came, and finally Tim Berners-Lee invented World Wide Web. So, now we are using social media sites for our communication, quick communication from point A to point B. So, lesson number 1 was regarding that portion. Lesson number 2 had elements of a communication system. So, there were 3 basic typical elements of a communication system, which was transmitter, there was a channel, there was a receiver. So, basic elements of what is a transmitter, what is a channel, channel is wired or wireless, then a receiver, what is the main function of a receiver, what is the type of signal. So, a transmitter always only has or only can bypass or only can transfer those signals which are electrical signal in nature. So, a non-electric signal has to be converted first into an electric signal, which can be done with the help of a transducer, and after it is being done, then the transmitter transmits the wave or transmit the message signal to the receiver through the channel. So, channel can be either wire or wireless. Finally, at the receiving point, we need to retrieve the information in the original portion, in the original part. So that in that way there has to be a there has to be a process in which the information is being converted from an electric signal to a non-electric signal again, so that we can understand the signal or understand the message which is coming from the source. And finally, it can be put to good use, any use which you require. So this was the concept we talked about in lesson number 2. Then in lesson number 3 we talked about the basic terminologies used in electronic communication system. We started with transducer, then we studied about signals. There were two types of signals, one was analog signal, one was digital signal. In digital signal we got to know a little bit about binary systems, how the computer understands the code. Then we studied about the bandwidth, then we studied about amplification. We also studied about range. What is a range? So range is the maximum distance the signal can cover with sufficient strength. Then we studied about the concept of modulation, we studied about demodulation, we studied about attenuation, we studied about range, we studied about frequency, we studied about repeater. So the final concept in basic terminology was about the receiver. What was a receiver? Receiver was being used for which consists of both a transmitter and a receiver. Next concept was about bandwidth of signal and bandwidth of transmission medium. So in this we concluded or we understood the concept about frequency ranges. So what is the different types of frequency ranges being allotted to different medias. For example, for a message signal or for a voice signal, a little less frequency range is required in terms of kilohertz only, as a human ear can hear only in the range of 20 hertz or 20 kilohertz. Hence the frequency range of 20 kilohertz or approximately 20 kilohertz is sufficient for the passage of information or passage of voice signal information from point A to point B. Then we studied about the frequency range of bandwidth for a picture, then we studied bandwidth for a video, then we studied a bandwidth for a video plus a voice signal, which is more than the a single video with no sound. Then bandwidth of transmission medium which was being done. Meanwhile, we also studied about in the lesson number 6 about propagation of electromagnetic waves. We studied about surface wave propagation, that is using grounds. Then we understood the concept of sky wave propagation, that is using sky as a total internal reflection using the ionospheric layer and then going to the receiver portion. Then we studied the concept of space wave, that is using the space. So in space either we can go for line of sight communication or we can go for satellite communication. So that was being told about told in the concept of propagation of electromagnetic waves in this lesson number 6. So line of sight communication problem was also being solved in this a simple formula, that is the total distance is equal to under root of 2r into height of the antenna plus under root of 2r into height of receiving antenna. First was transmitting antenna and next was height of receiving antenna, was being talked in lesson number 6. Then in lesson number 7 we understood or we came to the conclusion of why there was a need for modulation. So modulation is nothing but a process which we also talked about in lesson number 3 also when we were talking about basic terminologies. So in modulation and its necessity, we talked about the procedure of modulation, the definition of modulation, which is the method or the process by which a low frequency wave has to be imposed or has to be imposed added up with a high frequency wave, which is known as a carrier wave, for its passage from point A to point B. Why was there a need for the low frequency range, or why does a low frequency range could not pass through long distances? We learned 3 factors about it. First was the size of the antenna, second was the energy radiated by passing, which was directly proportional to 1 by wavelength squared, and third was mixing up of signals. Using these 3 factors we got to know what was the need for modulation to be done. Then there was a mathematical formulation in which we got to know about the different forms of sinusoids which we get. There was a DC term, that is C into AM square plus AC square by 2, which was being rejected by a band pass filter. Then the frequencies only concerning with omega c point, that is omega c plus omega m and omega c minus omega m was being accepted or was being passed through the band pass filter, and that was being received by the receiving antenna. Then finally at the receiving antenna portion we also, so in this concept of modulation and its necessity and amplitude modulation, we got to know about different so production of the amplitude wave and amplitude modulated wave and the receiving of the amplitude modulated wave. Make sure just a little bit brief again about the modulation. So there were three types of modulation being talked about. So, first of all, modulation, as the concept or the equation for modulation was AC or A into sine of omega t plus phi. So, because except t there were three terms, one was A, one was omega, one was phi. So, hence modulation can be of three types. Typically one is amplitude modulation known as AM, next was frequency modulation known as FM, and third was phase modulation known as PM. So, this was the concept of modulation. To summarize in the last 3 to 4 minutes, let me iterate quickly. So, this is the final summary. Let me go over here quickly, and that will be the end of communication systems. So, now in the present chapter we have discussed some basic concepts of communication and communication systems. We have also discussed one specific type of analog modulation known as amplitude modulation, which was the last concept of this chapter. Other forms of modulation and digital communication systems play an important role in modern communication. Modulation is very required in day to day life. These and other exciting developments are taking place every day. So far as we have restricted our discussion to some basic communication systems only. So, this was being constricted to basic communication systems. If you go on further for engineering types, then you will get to know more about these devices. So, electronic communication refers to faithful transfer of information or message from one point to another. Transmitter, transmission channel, receiver are three basic types, as I already told you. About analog and digital type, I already told you what were the two types of signals. In next concept, we already know a message signal can be of different types. Concept of bandwidth is being talked about here. So, similarly, any practical communication system permits transmission of a range of frequencies only, which is referred to as the bandwidth of the system, which is being talked about here. Next is low frequencies cannot be transmitted long distance, which was the basic concept of the modulation. So, low frequencies cannot be transmitted to long distances, therefore, they are superimposed on a high frequency carrier signal by a process known as modulation. So, this was the process of modulation which was talked very clearly in the last lecture, last to last lecture. Then there were three types of wave, as I already talked about. One was AM wave, one was FM wave, one was PM wave. In the pulse modulation, there are again three types. One was PAM, that is pulse amplitude, next was PDM or PWM, and the last was PPM. Then for transmission in the long distances, signals are radiated into space called as antennas. So, in this concept of 8th and 9th, concept of space wave, ground wave, and sky wave is being talked about. Total internal reflection was being used in sky wave. So, this was the concept talked about in 8th and 9th point. You can understand it carefully, these are just the summary of the NCERT book only. Finally, if an antenna radiates electromagnetic wave from a height ht, then the range dt is given by under root 2 r(ht), which I already talked about when I was talking in the course progress slide. So, where r is the radius of the earth, which can be taken as approximately as 6400 kilometers. So, amplitude modulated wave, so this is also being done. Next is amplitude modulated signal contains frequency of this, as the band pass filter only allows these frequencies, which is omega c, and sideband, that is omega c plus omega m and omega c minus omega m. So, this point is also done. Finally, amplitude modulated wave can be produced by application of the message signal and the carrier wave to a non-linear device followed by band pass filter. So, non-linear device was nothing but the square law device which outputted or which produced the output of y of t, which is b x of t plus c x square of t, and finally, the mathematical formulation was being done in the last two lectures, and band pass filter just passed or rejected the DC terms such as c into am square plus ac square by 2 and abstracted or passed the frequencies having omega c minus omega m, omega c and omega c plus omega m. Finally, AM detection, which is the process of recovering the modulating signal from an AM waveform, is carried out using rectifier. So, rectifier was being done. So, there were two types of wave like this. After rectifier, there was only one type of wave like this, not like this. Just to make it more clear, it was like this, then it is like this, and finally, we will get a message signal, our original message signal. So, this was the complete concept of communication system. I am sure I make it quite easy now for you to understand communication system. Please go through this, every concept is being talked about very clearly. Only two problems were detected. One was regarding if the distance is being required in a LOS communication, and second was regarding the modulation index and sidebands. So, thank you so much for your precious time. So, this is the end of communication systems. Thank you.